Assalamualaikum and good day everyone. So today we will at last chapter in chapter 4, which is 4.7 application of motion of a charged particle. So for learning outcome 4.7a, you have to explain the motion of a moving charged particle in magnetic field and electric field for V, B and E perpendicular to each other. Magnetic field is B and electric field is E, and use the velocity V is equal to E over B in a velocity selector. Alright, so consider a positively charged particle with mass m, charge q and velocity enters a region of space where the electric field and magnetic field are perpendicular each other. Okay, macam mana kita tahu perpendicular each other? Alright, so kita tengok kat sini the direction of E. Okay, this is the direction of E. P is into the page. Okay, so V is straight. So by using our right hand. Assalamualaikum and good day everyone. So today we look at 4.7 application of a motion of a charged particle. 4.7a, you have to explain the motion of a moving charged particle in magnetic field and electric field, and then you have to use velocity V equal to E over B in a velocity selector. Okay, we consider a positively charged particle with mass m, charge q and velocity v enters a region of a space where the electric and magnetic field are perpendicular each other. Alright, so this is the figure where we look at this figure where B is into the page, okay, and the direction of E is from positive to negative plate. Okay, the charge will experience the electric force downwards. Okay, this is clue number 1. Okay, macam mana kita tahu? We use our Fleming left hand because the charge is positive. Okay, so B is into the page. B, okay, B is into the page. V is so the FB is upward. Okay, FB is upward. Okay, using our Fleming left hand rule, so FB is upwards. Okay, and FE is downward. Kenapa FE downward? Because positive charge is attracted to negative plate. Okay, FE is downward, so positive charge attracted to negative plate. Okay, if the particle travels in a straight line with constant velocity, hence the electric and magnetic force are equal in magnitudes. Okay, constant velocity in straight line. So FB is equal to FE. So we can have here, so Q we cancel off. Then we have V is equal to E over B, where E is the electric field and B is the magnetic field. Okay, only the particles with velocity is equal to E over B can pass through without being deflected by the fields. The velocity selector normally used as a mass spectrometer. Mass spectrometer ni is an analytical technique that measure the mass to charge ratio of ions. Okay, so kat sini kita dapat ni dia punya figure. Mula-mula kita punya elektron tu, okay, pass through the electric field and then pass through the magnetic field. Okay, so kat sini V straight line, not deflected. Okay, and then dia akan masuk ke dalam mass spectrometer ni with ion positive. Okay, so kat sini pada stage number 1 ni kita ada FB equal to FE, when QVB equal to QE. So we can have V is equal to E over P. Okay, this is how we can find the velocity for this stage. Okay, stage number 1, where we have a parallel plate charge. Okay, so then dia akan masuk pada velocity selector ni. Alright, so kita tengok, kita using our Fleming left hand rule. Okay, so determine our force. P is into the page. Okay, B into the page. Use your first finger, and your second finger is your V. Okay, so kita boleh tentukan arah kita punya F. So F, B, V. So F ke atas. So sampai sini. Okay, F, B. Okay, F is upward. Okay, so bila kita letakkan kita punya jari kat sini. Okay, stage number 2, FB is towards the center of the circle. Okay, FB is towards the center of the circle, so we can have here FB is equal to FC, FB is QVB, and FC is MV squared over R. So we can have Q BR equal to MV. So R is equal to MV over QB, where R is the radius of the circle. It's the radius of the circle. Okay. Tengok soalan. Alright, so dia cakap apa? The figure shows a uniform magnetic field directed into the paper. Electron, okay, enters the region of the magnetic fields as shown. Show the path of the electron as they pass through the region of magnetic field and exit from side B to C. Okay, so exit area sini. Okay, label the path as A. Also label the magnetic force on the figure. Okay, so kita nak dapatkan kita punya electron. Okay, so electron dia akan straight. Okay, ini adalah direction of E from positive to negative plate. So P is into the page. So kita akan dapat kita punya tangan kanan lah, tangan kanan untuk Fleming left hand rule, untuk Fleming right hand rule, untuk charge electron. So velocity is upward. Okay, so kita akan nampak kita punya force. Okay, so this is the direction of V, this is V. Okay, direction V lah macam ni lah. So kita akan nampak electron tu dia akan deflect ke melalui sini. Okay, A, V. Okay, so direction of FB ke sini lah. Direction of FB to the right hand, to the right. So dia akan keluar BC sana. Okay, so kita dah label path A. Also label the FB. Okay, FB here, FB to the right. Label FB to the right, so FE to the left. Okay, so A. If the electron enters the magnetic field with higher velocity, okay, show the path of the electron and label the path as B. Okay, dia masuk with higher velocity. So kita tahu FB sama dengan FC. So QVB equal to MV squared over R. So we have QBR equal to MV. So here we can have our R is equal to MV over QB. We can have here R is directly proportional to V. Okay, R is directly proportional to V. So when we increase the radius, the radius is also increased. So radius also increase. The path will be like this. Okay, dia akan lagi jauh sikit. Okay, ini path B. Okay. Alright, so dah C pula. State the two situations in which electron in a magnetic field does not experience any magnetic force. So either the charge is stationary in magnetic field ataupun charge moving parallel to magnetic field. Masa ni theta equal to 0 degree. Kan kita ada magnetic field dah sebenar. Okay, FB kan, FB is equal to QVB sin theta. So bila charge stationary V kosong, so FB pun akan 0. So bila sin 0 ingat theta ni is the angle between V and B. So bila V moving charge parallel dengan B, theta 0, so FB is also 0. Okay, D seterusnya. A uniform electric field is supplied across a region ABCD in such way that the electrons are now not deflected. Mark on the figure the direction of the electric field. Oh, electric field. Kita dah labelkan tadi. This is the direction of electric field. FE. Okay. Alright, seterusnya E. Derive an expression for the velocity in B. Okay, in B. Okay, in terms of electric field and magnetic field B. So FB equal to FE. So QVB equal to QE. So V equal to E over B. Okay, E over B. Number 7, physics exercise. Figure shows a positively charged ion pass into velocity selector where the magnetic field is 100 millitesla perpendicular to an electric field of 1 kilovolt per meter. A magnetic field of equal magnitude is used to deflect the ion in a circular path with radius 15 mm in a deflection chamber. Calculate the velocity of the electron. Okay, so macam mana kita nak tentukan velocity of electron kat sini? Kita dah tahu dah B 100 millitesla, -3. Dia punya electric field E 1 times 10 power of 3 volt per meter. Magnetic field, the same magnetic field, can be sama lah. Radius is 15 times 10 power of -3 meters. Calculate the velocity of the ion. So FB is equal to FE. So we have QVB equal to QVB is equal to QE. Equal to QE. Sebab FE kan sama QE, so Q B is equal to E over B. E is 1 times 10 power of 3. B is 100 times 10 power of -3. So we have 1 times 10 power of 4 meter per second. For the mass of the ions, we use FB equal to FC. So QVB equal to mv squared over R. So kita ada kat sini QVR equal to mv. So m equal to QVR over v. So Q 1.6 times 10 power of -90. B is 100 -3. Radius 15 times 10 power of -3 bahagi dengan velocity yang kita dapat 1 times 10 power of 4. Okay, so kita dapat mass kat sini lah. Mass is 2.4 times 10 power of -26 kilogram. Soalan yang kita buat tadi adalah soalan tahun 2017-2018. Alright, so kita dah settle dah A dan B. Alright, so nanti you boleh jawab juga soalan-soalan ni. Okay, kita nak tengok number 42. Kita ada 5 marks here. Okay, an electron moves with constant velocity through the electric field and magnetic field. Given the magnetic flux density and electric field strength, show the direction of electric force and magnetic force. Okay, so the direction of V is here. This is the direction of V. Okay, so using our Fleming right hand rule. Kenapa nak guna right hand? Sebab dia adalah electron. Okay, so kita gunakan Fleming right hand. B is into the page. V. Okay, so FB is downward. So our FB, so our FE is upward. So kita dah show the direction. So kita dapat markah kat sini. Macam mana markah? Satu markah. So macam mana nak tahu direction tu? Gunakan Fleming right hand rule. So your thumb. Okay, sebelum dapat thumb, kita letak yang lain dulu lah. So jari telunjuk ataupun first finger into the page. Ini nak tentukan B. And then second finger ini nak tentukan V. So ikut saja arah tu. So you akan dapat nanti. Okay, FB is FB ni lah kita punya thumb. Okay, calculate the velocity of the electron. So FB sama dengan FE. So QVB equal to QE. So V equal to E over B. So E 0.00, B 0.0076. So dapat V. Okay, tekan calculator. 7 3 7 10 power of 9. Okay, kita tengok 42 betul tak? 42 ni. Okay, tu. Okay, so nanti boleh try lah soalan-soalan ni. Okay, so thanks.